Hello there and welcome to this video. My name is Valentine and I'll be your instructor. In this video, we're going to be going through day 21 of the Pandas Library Challenge. And this generally will entail going through a set of Pandas concepts that are important for data analysis. So let's get started. The first thing that you need to do is to visit the description section of this video, and you should find a practice resource link that will direct you to this page that you're seeing on your screen. Once you get here, click on the sample practice resource, which should take you to the notebook that we'll be using. This notebook contains the concepts as well as examples and a few challenges. However, if you want more challenges that would be helpful in your learning journey, so we have curated a practice notebook that you can get by becoming an Afterwork member, and you get all the other resources that you need in relation to Pandas, whether it's for data analysis, data visualization, machine learning, at your disposal. Right, so let's get started. Once you get to the sample notebook, you need to go to File, then Save a Copy in Drive to have a copy of this notebook saved to your Google Drive. Let me just zoom in a bit so that you're able to see the screen much more clearly. Okay, so once you get to Save a Copy in Drive, it will open in a new tab, and then you can use that one. You can close the original copy. I will be using the practice notebook, which will generally the practice notebook that I'm going to be using, you will contain more challenges. So you might realize there are no challenges in the sample because it's a sample notebook. Okay, for Afterwork members, you can use the practice notebook. Right, so once you get here, once you get to this particular point, by the way, feel free also to pause the video and do what I am doing, just in case I'm too fast. Then you can unpause the video. Once you get here, click on prerequisite and then run the first code cell. And this should import the Pandas library. So let's do that. Initially, it takes a few seconds because it also connects your notebook to Google servers, which are the servers that will be running our code. So we've imported the Pandas library using the code that you see here, import pandas SPD. Let's go through the first concept. In certain cases when we are doing data analysis work or data analytics work or data science work, we might want to create pivot tables, and using Python, we can use the pivot table function to create a pivot table, which is just generally a summary table, a shorter or not a shorter, but a smaller table that can be derived from a bigger table. So assuming we have this data set that contains data, which you can see information about insurance claims. If we wanted to create a summary table of, from this particular table, and the summary table might contain claim type and claim amount, or the sum or the total of the claim amount for each claim type, then we can use the pivot table as shown. We reference PD, that's the Pandas library, and we use the pivot table function from the library, and we pass the data frame that we have used to load our data to, and we set the column on the left using the index parameter, and we set it to claim type. This is the column, which would be categorical in nature because we are sort of grouping by we're grouping our data by this column type, and the values, or the column that's going to be on the right hand side, that's claim amount, we set it to be the values for the values parameter, and we set the aggregate function as sum to apply the sum function to the claim amount for each and every claim type. And then we apply just the reset index function to just ensure that we have a Pandas data frame output, and then we display the pivot table. Yeah, so that's just generally it. And here we have a pivot table that we could use for creating maybe a bar chart or a pie chart or any visualization that might be useful. Right, pause the video and then work on the challenge. In some other cases, we might want to convert maybe some categorical data, maybe some columns that have categorical data. Say, for instance, we might want to convert all the categorical data. that has been stored initially as string or textual format. So initially, when we load this data set, we can see that if we run this code d types, if we apply the property to the df data frame, we can see that the policy holder name has an object data type, same case with policy type, claim status. And this is just textual data. It's a classification that would normally be given by default by the Pandas library to these columns because they contain text data. But if you want to efficiently store this data, instead of using the object data type or having that object data type assigned to that column and then using that column for analysis, we can convert that column, or we can assign that column a categorical data type that generally allows us to be able to efficiently store the data that we have in the categorical variables that we have. So here, what we can do is select the columns that we want to work with, and we can use this method to select the columns with a specific data type. So select data types, and we set the include parameter of the select data types function to this list that contains the object. That's the type of data or the data type that we want to get. So this particular statement over here will select all the columns that contain the object data type, and we store those columns inside the object calls variable, which we pass to the df data frame, which this is just a way of just selecting the columns from the data frame that we see here, using the square bracket or the brackets to be able to just select the columns themselves. But again, we apply the category data type by using the asType function. And generally, we replace what was there initially with now the result of what we have here, which is now the assigned columns with the category data types, and then we preview the new data types. So here you can see that we have all the columns that we had the object data type have now a category data type. All right, pause the video and then work on the challenge. In some other cases, we might want to optimize. Just as we did, or we might want to check for how much memory the data or the columns contain, or the data frame actually consumes when it comes to being loaded onto your computer. So we can use the memory usage function. So if we load this data set, it will be allocated some memory, and if we want to display the consumption of that, we just apply the memory usage, and we can be able to see that these columns have been assigned the following information. But we can also use the info function to be able to also get some total of some total that just describes how much memory altogether the entire data frame has been assigned. So that's what we get. So we can use memory usage or info for collective or for some or it all. Pause the video and then work on the challenge. When it comes again to data analysis, we can decide to select the data that we only need for our analysis, for answering a research question. And hence we might perform a filtering techniques. We might perform many filtering techniques to be able to help us out with that. And one of the filtering techniques that comes in handy is the isIn function, method, and this allows us to be able to specify the values that we would want the values that we would want for the records that we want. So for example, if we wanted to select maybe records with maybe claim amount of 5,000 and 10,000, then we can use this method to specify that those are the records that we want. But here we are specifying the values for now our condition using just two lists, claim types and claim statuses, which we pass to the isIn method, which again will again help us just in that filtering process, which will be just generally be part of our condition. So that's the first condition, and the second condition is set here, and we actually use claim statuses for here. And these are two conditions that we combined using the AND operator, the ampersand operator. So not the ampersand, just a character, but the AND operator that we use. And then we filter. We showed the defiltered data frame as shown here. Pause the video and then work on the challenge. In some cases, we might want to, instead of just filtering, we might want to delete rows by condition. So we might want to define, first of all, the rows that we don't want, and then select the rest of the data. So assuming that we had this data set, again, that contains insurance claims, we can then decide to select maybe these records. So assuming that we wanted to not work with these records that have a claim amount greater than 5,000, less than 5,000, we can select those records and then get their indexes by applying the index property to the specific condition that we have, and that will give us the indexes of those particular records, which we then pass to the drop function, and apply the drop function to the original data frame to just delete those rows with that with the specified indexes. Then lastly, we just display the data set. All right, pause the video and then work on the challenge. In some cases, we might want to get a representative, a sample, or just some records which are representative of the entire data set. We might maybe want to get a fraction. Instead of just saying how many records, just specify maybe 20%, 10%. So assuming that we had this data set and we wanted to get maybe a representative sample, using simple random sampling, where each and every element in the sample would have equal chance of being selected. If this data set contains 100 records and 10 columns, then we can use the sample function to we can use it to get the sample that we want. We apply it to the original data frame, and we specify the frac parameter to have a value of 0.2 to specify that we want 20% of the data frame, 20% of the records to be part of the sample, and we specify random state to just have reproducible results. That way, if you also run the code when you also have random state as 42, you'll get the same results as I would. If you change the random state value to a different value other than 42, you'd get different results. So if I run this, I should be able to sample. So my sampled records are here, but to get the size of the sampled records, I can run this code. We should get around 20%, should get 20 records. 20 records, 10 columns, and we can display the sample. All right, pause the video and then work on the challenge. In some other cases, when we are working with data, more specifically date time data or columns, we might want to maybe work with some unique date frequencies or offsets, called date offsets. So maybe we might want to create maybe a custom date offset for 15 days or every 6 hours. And this might be the case for maybe some context, maybe in financial data analysis, not necessarily in all types of analysis, but yeah. So this is just an implementation of how we can be able to work around that or work towards that. So assuming this is our data set and we wanted to this is our data set, as you can see there, we wanted to define a custom offset for every 2 weeks. First of all, we would need to ensure that the date column that we want to work with, which is this one, has a date time format. And then we define our custom date offset for every 2 weeks, which we do here. And we then apply that to the date column that we want to work with, that's claim date. And we should be able to get now new date for every 2 weeks. And we can display that. And you should be able to see that we have the original claim date. But again, the new date has, which appears after every 2 weeks, appears on the claim date custom column. This may not be useful in many cases, but in some cases, especially in financial data analysis, that could be important. Right, pause the video and then work on the challenge. Filtering rows using between and inclusive. Well, this between, when you use a between function, we can be able to actually achieve what we're talking about in here. So assuming that you wanted also to filter for records, but include the boundaries of what you have defined in that particular filtering process. So assuming you wanted to get the records that have a claim amount between 5,000 and 8,000, inclusive of 5,000 and 8,000, then we can just use the between function, which will set that for us. It actually define such that it will actually ensure that those records with also 5,000 and 8,000 have been selected. And if you run this, you should be able to see even 5,000 at the very top has been selected, 8,000 has been selected. Pause the video and then work on the challenge. When we are working with data, sometimes you might want to convert the data to have some sort of case, maybe uppercase. So in our case, how do we implement such an operation? So assuming we had this data set and we wanted to convert the columns, the respective columns, be short name, claim type, claim status, to uppercase, we can just simply define the column that we want to apply that method to, and then we apply the method to that particular column as shown. So this is just a string method to upper. We ensure that our data is actually standard. Assuming that you had a data set that had lowercase column names, I mean, you'd do the same. This is uppercase. You could also use other cases. This is just one of those cases. This is, again, it may not necessarily be applicable in our context, but for just learning how to perform that operation, then it might be important. All right, pause the video and then work on the challenge. Lastly, we might want to capitalize the first letter in a column, just as one of many other text pre-processing techniques that we might perform. So assuming we had this data set and we wanted to possibly capitalize the first letter, maybe you could do the same thing. I think here it may not be able to show, but again, we can use another method, a string function, just like upper. Just here we can just use capitalize to be able to capitalize that. I think this would have worked better for a different data set. What if yeah, you could have worked better for another data set, but again, this is how still you're able to perform this operation. Right, pause the video and then work on the challenge. All right, so that's it with regards to today's learning journey. This is today's Pandas library challenge. We hope that you are able to get some value out of it, and you are getting better and better, and you feel like you can use Pandas for data analysis work whenever you'd want to perform data analysis work. You might even decide not to use some other basic tools if you realize maybe Pandas can help you out. If you did like this learning experience, you found it valuable, and be sure to give this video a thumbs up. It just tells us that we're doing a good job, and more people will also be recommended the same. And if you'd want to be informed when we post such future learning experiences, and you haven't subscribed yet, be sure to subscribe. And yeah, see you in day 22 of the Pandas library challenge. All the best, and see you soon. Bye-bye.